Hello, I'm Charles Rice, and this is
Gilani.
And we're two cloud solution architects in the customer success unit for Microsoft Education. We truly see our customer success as Microsoft's success. In order to achieve that, our goal is to create real value for our customers by using our products. What we mean is create value across the institution, from a very high level to faculty, staff, research, and last but not least, students.
I would say more than that, Charles, because if you see the customer nurturing cycle here, we start with engaging with the customers, transacting with them on each and every phase of their progress, and actually helping them in the adoption of the Microsoft Cloud much easier, much simpler, and a customer keeps getting the growth cycle increase every time we repeat this cycle.
Data science and research analytics are two really hot topics right now, especially in Azure. And what we've done to make sure that you're ready to go to start conducting that research in data science in Azure is we've created training videos, case studies, labs, hackathons, templates, and much more.
So stay tuned, there's lots of more fun coming on these areas. Myself, Charles, and my team are creating lots of material here. So keep watching, keep providing the feedback to improve all this content. Thank you very much for joining.
Thank you. Thanks for joining us. My name is Charles Rice, and this is
Gilani.
And we're two cloud solution architects in the customer success unit for Microsoft Education. And we're here today with two very bright and talented soon-to-be graduate students from the University of Texas at Austin. This is Tiffany, this is Kirti, and I'll let them tell you a little bit about themselves.
Hi, I'm Kirti, and I'm currently doing my master's in business analytics from the University of Texas at Austin. And right now we are here to try out some data science projects for you guys on Azure. And if you would have seen the previous video, you would have seen how easy it is to actually set up Azure notebooks on your system. And without any hassle of compute power, you can run whatever kinds of projects you want with as much amount of data you have. And we'll just be showing you a few examples that we think are relevant.
So, hi, I'm Tiffany, and I'm also a UT Austin business analytics student. So today we're going to do on a climate change project. So we know that right now climate change is a big deal. So in this project, we're going to look at how the temperature changed across time. So let's get the project started. So first, open our notebook, and we're going to import the libraries. Look at the first cell. We're going to import Matplotlib, which is a data visualization package. And the second one is NumPy, which is helping us to deal with several kind of data structure. So the third line is that we want to import linear regression from scikit-learn. And scikit-learn is actually a package that help data scientists to do machine learning. And it got lots of model into it. And the last one is we're going to import Seaborn, which is also a data visualization package, but which is fancier than Matplotlib.
Okay, so I think that's pretty interesting, right? So even though this is running on Azure, you're not bound to just using Azure machine learning services. You can import scikit-learn or MLlib or whatever library or package you're comfortable with, and use that instead of being bound to our tools. Awesome.
Okay, so if you finish running the first cell, we make sure that we successfully import all the package. Let's do the second cell, which is load in dataset. So actually in Azure, we can load in dataset in various methods, but in this project, we're going to load in dataset from locals. Let's first click on File and Upload. It will direct you to the folder you store your dataset. And once you select the dataset, you just click Open, Upload, and go back to your project. You can see that the dataset we're going to use is already in our project. So in this way, we can load into our notebook.
Oh, so now that it's in your project, you can refer to it locally within the notebook session, right?
Yes. So you can see the two datasets we're using. The first one, we're going to load in as year-based and mean-based, which this dataset is starting from 1951 to 1980s. We're going to do training on our model using this dataset. And the second line, years and mean, which we loaded our dataset from 1882 to 2014, which is going to use on showing the entire period of time, and we're going to do prediction on it.
So you're using one data set to train on and the other one to test that training to see
Yes.
if it's okay.
The idea is this. So after we successfully load in our data set into our notebook, we're going to first do a scatter plot on it to show how the data looks like. So in the scatter plot, you can see that the temperature have an upward trend across time, but also have a fluctuation in it. So we're going to do a linear regression on it to see how the trend is going on. And I'll let Kirti to talk about that.
Thanks, Tiffany. So now we'll be getting into modeling. We are just going to try out some basic linear regression over here. And there'll be three methods we'll be trying out. One, we'll be using NumPy with Matplotlib. Next, we'll be trying our hands on scikit-learn's linear regression function with Matplotlib. And finally, we'll be trying out Seaborn. So first, let's look at the NumPy method of fitting a linear regression model. So over here, we'll be utilizing the polyfit function to fit our linear regression on the data set, the training data set, as Tiffany mentioned. And we'll be plotting it using Matplotlib. So after obtaining the intercept and the slope values from the polyfit function, we'll be utilizing that to generate our equation, which is our y is equal to mx plus c, because we are using only a degree equal to 1. And on running this, you can see that the points are our original data, and the line is our trend or the linear regression line. And below that is the equation for the training data. And so this is our model which has been fit for the training data, and now we'll be trying it out using scikit-learn. As Tiffany mentioned, scikit-learn is one of the most popular Python libraries, and we'll be using the linear regression function from it and fitting the model. So over here, you can see that we've done that, and we fit our model on our data set, and then we predict it for the same data set because we are training on that. And on running it, this is what we get. You can see that it's the exact same equation as that of the one we obtained from NumPy. So both of them are giving us the same results. And so those are the first two techniques. Now we'll be moving into Seaborn. So as Tiffany again mentioned, it's a fancier version of visualizing our data. But apart from that, Seaborn also has the ability to literally run regression and plot it in one single line, and that's what we will be doing. So with Seaborn, what we'll be trying to show right now is that we'll be plotting our data using a normal scatter plot using Matplotlib for our training set, but we will be predicting using the Seaborn regression plot function for the testing data set. So from that, we will get a few insights, and let's see what those are. So on running this is our output. Now our training data set lasted in between these years. It was somewhere between 1951 to 1980, and the testing data set lasts from 1880 to 2018 or 2018 actually. So the line is our predicted what we predict and what we predicted the climate to look like or the temperature change to look like. However, this is the real data which has been observed, and we can see that till 1980 everything was good, but beyond 1980 nothing is confirming to what we actually predicted. So we can clearly say that climate change is going way beyond what we predicted, and global warming is a real thing.
Wow, so two things. First of all, that's impactful, right?
Mm-hmm.
You look at that chart and obviously something's going on. But secondly, that was very easy to do.
Yeah.
And I think that just goes to show the power that Microsoft's enabled you to have by providing services like this. And not only that, but it's also free by default too. So
also, although yes, we can utilize Jupyter for it simply on our local. However,
sure.
Running these codes on Azure are so much more faster. They literally take less than a few seconds just to run big pieces of code, and we've tried it out and we found it to be really
Yeah, not only that, so that's the free compute, but you could also spin up a much more powerful data science virtual machine to run as the compute and make it even faster.
Exactly.
Right? So
Well,
Awesome.
At this point, I think one question is bothering my mind.
Sure.
And Keith, Charles, who would like to answer this? I saw these libraries,
Mhm.
they are built in. How can I make sure they are always the updated libraries and I'm not working on the older libraries? Is there a way to make sure?
Yeah, so this is Python, right? So it's just like you would in any other Python experience. You would just, you could check the versions in Python, so version, or to see which version you're on, see if it's a compatible version, or you could just, at the very beginning, append pip install update for every library, so you're always up to date for the most recent versions. All right, awesome. Thanks, Tiffany. Thanks, Kirti. And thanks, everyone, for joining. This was, like I said, very impactful and a great demonstration, and shows you really the power that you have with these services.
I'm so excited to try it myself. I'm telling you.
Yeah, no kidding, me too. And like I said, this is a series of videos. This is number 2. The first one was an introduction to Azure Notebook, so it shows you everything you need to get up to this. It's a very short video, maybe 10, 15 minutes, setting up your environment and all the cool capabilities you can do. This was on climate change. We're also doing one to predict airline delays, and last but not least, sentiment analysis on text. So stay tuned.
Artificial intelligence is fueling the next wave of transformative innovations that will change the world. With Azure AI, our goal is to empower organizations to apply AI across the spectrum of their business.
We are developing the tools to enable anyone, not just PhDs or researchers, to harness the most powerful AI supercomputers in the world in order to overcome their problems, no matter how complex.
We are moving beyond big data and machine learning capabilities to be able to infuse cognitive capabilities.
I think Azure for research with the cognitive services and the machine learning capabilities there are phenomenal to help researchers actually maximize their time. They spend less time building and maintaining systems and more times actually implementing and doing the studies that are necessary for this research.